This is database and SQL, CIS-332, and today we start off with talking about this whole idea, users and apps. We came to that, languages and users, and we talked a little about API, and we looked that up, and we then referred to what the user sees, and we split up some items in terms of the database. We have this external view of the database, then we have the conceptual view, and if you remember, we had where we talked about just the entities and the relationships. Alright, entities and then the relationships. And we talked about this the other day. And then we broke that down into logical tables. Then eventually we go down to the internal, the actual storage, the specifics of how the information is written. We have structured query language, which allows us to access that. And you can write, here's the concept, we can have structured query language, and we can have any kind of app write code that accesses that SQL. Putting that all together is a relational database. Years ago we started out with flat files. We would have the information and then some marker and then the next piece of information, the marker. And here, for an example, I'm showing carriage returns. I used to write that out to, well, actually it was on cards for a while, and then that moved to tape, which we ran from reel to reel. We write the information on there. So here's the example we did the other day. We talked about donations. We used like a church, but you could think of most nonprofit organizations. They have people who give. Here we call them members. And then we also had an entity of employees. Not really worried at this point about any of the attributes or characteristics of these. And then we worked a little bit on the relationship. For example, a member and an employee could be a one-to-one relationship. An employee could be a member, and a member could be an employee. The member can have a relationship to the donations. One member can make many donations. Same thing with the employee. One employee can make many donations, but each donation belongs to one member. We're going to make reference to this more so later on, but you can actually build a table that lists all the attributes and a description of each of those. We'll talk about that here in a little bit. Down here, a student had a question about assembler language and talked about loading information in the registers, doing some kind of work on the registers, and moving that information back and forth to memory. And then the last thing to tie this together, we talked about some of the final things in section 2. And we started out talking about entities and then characteristics that define the entity. For example, over there we talked about members. Let's say members of a church or organization. Those members would have certain characteristics that would define them. For example, name, and then maybe date of birth, and so forth. Not saying this is exactly how we would organize it, but just thinking about that. So those attributes are the characteristics that define the entity. First thing we mentioned then, they could have a certain type. For example, if you had an attribute called first name, that would be some type of attribute. For example, that could be made up of characters. Variable character length, sometimes referred to as text, and then that could have a constraint in terms of how big it could be. You know, how many characters are you going to allow for the first name? There's no sense allowing 255, but you'd probably want to allow more than 5, so you come up with some constraint. Now, constraints are used for a lot of different things in a database. For example, a member can make many donations. So we have a constraint that each donation only could be from a particular member. So constraints, you'll hear us use that a lot. Right here, we're going to use it in terms of attributes. A description, I showed that you could create a specific table or entity that describes all of your attributes in all the tables. And then we talked about these down here, a single value attributes. Probably a good example, maybe first name. You really can't divide first name into things, except you could divide it into each character, but that really wouldn't have much relevance. A multi-valued, a good example would be a date of birth. So if you have somebody's date of birth, okay, so let's say they were born 3/10/62, okay? Even though you'd like to probably store that in one attribute called birth date or date of birth, it really can be broken into multiple things. We can get the month, the day, and the year. So you can split it up so that could be divided. It's not indivisible, it's divisible. You can divide it up into different parts. So that'd be a great example of a multi-valued attribute. A composite attribute is actually a little more than a multi-value attribute. That would be like an example where a database gathers just the name. You know, they want your name, so they want your first name, maybe your middle initial, and then your last name, and they put all that in one attribute. So that would be a composite because it really contains multiple things that aren't really, they're related to each other but not tied together, not like a birth date. So that would be a composite. Then the last thing, we talked a little bit about keys. Primary key uniquely identifies the objects or records in a table. Attributes can be derived. We can get an attribute that's derived from either a formula, or we can have the database automatically create primary keys. If there is nothing to put in a particular attribute for a particular thing, we can say it's null, doesn't apply, and that's different than it missing. Okay, it's different than if a particular thing would be missing. So we could have a number of different examples of those things. You might be gathering information about people, and then there's a certain field that it just doesn't apply for somebody, so you'd say it doesn't apply, or it might be missing. You might have somebody from Canada, and you're gathering Social Security numbers. Well, They don't have a Social Security number, so you can make it null. It isn't like the Social Security number is missing. A person from Canada just doesn't have a Social Security number if they're not a citizen of the United States. Kind of a crazy example, but it's the best I got right now. And that's really it for the whiteboard work from today.